This video will work through problem 7.1 from Gapenski's Healthcare Finance, 6th edition. So we're given some information in the problem. To start, we have a variable cost of $5 per visit. We have direct fixed costs of 500,000. We have annual overhead of 50,000. And then we have annual utilization of, or number of visits, of 10,000. And so question A says, what per visit price must be set for the service to break even and then to earn an annual profit of 100,000? So we'll start with the break even. So remember, from break even, from our last chapter, we were talking about if we have some amount of fixed cost, which in this case is going to be direct fixed costs plus overhead. And then we have our variable costs start at to get our total costs, we start at the fixed cost and add our variable cost, and our variable cost is going to go up, is going to be the difference here. And that'll give us our total cost. And remember, that slope is going to be 5 for the $5 per visit in variable costs. And then we're going to have, it looks like we're a fee for service. So that means that we're going to earn total revenues, and this is dollars and this is number of visits, right? We're going to get zero revenue at 0 visits, and then we're going to get the number of visits times the average price per visit going up here. And so we're looking for, and this would be total revenue. And if we're looking to have break even happen at 10,000 visits, we're trying to figure out what price would we have to charge at 10,000 visits to break even. So remember, our profit function is total revenue minus total cost, and total revenue is equal to price times the number of visits, and total cost is equal to the fixed cost plus the variable cost. And in this case, the fixed cost is going to be the direct fixed cost plus the overhead. And then the variable cost is going to be $5, right, times 10,000. And I guess I could have filled that in. So direct cost, 500,000. Overhead, 50,000. And then variable cost, 5 times 10,000 would be 50,000. Our total revenue is going to be price times 10,000 visits. So we can combine this and this. So our total revenue, so then our profit, we want to be 0 at break even, is going to be the total revenue, which is going to be 10,000 P, right? I'm just putting the 10,000 in front of the P. So that's our total revenue, minus 500,000 plus 50,000 is 550,000, plus 50,000 is 600,000. So we have 0 equals 10,000 P minus 600,000. So then I can just add 600,000 to both sides, and I would get 10,000 P equals 600,000. And then P is equal to 600 divided by 10,000, or 60. So basically our profit function became, for break even, was profit, which is 0, equals 10,000 P for revenue minus 600,000 in costs at 10,000. Now, the second part of part A says, what if they want to earn an annual profit of 100,000? So that just means instead of setting profit equal to 0, I'm going to set profit equal to 100,000. I'm just going to move this up here so we can continue to work with it. So we said profit is equal to 10,000 P minus 600,000, right? That's this. Now I'm going to say instead of setting profit equal to 0 to get break even, I'm going to set profit equal to that arbitrary $100,000. So I'm now solving for a price that will give me $100,000 in profit. So I'm going to add $600,000 to both sides. That gives me 10,000 P equals 700,000. And then dividing both sides by 10,000, I get P is equal to 70. So part A, the first answer for break even, where profit is equal to 0, is P equals 60. When I want to set profit equal to 100,000, right, then profit is equal to 70. Part B says, repeat part A, but assume that variable cost per visit is now $10. So now we have variable cost equals 10 per visit. Direct fixed cost is 500,000. Overhead is 50,000. And number of visits is still going to be 10,000. All right, so the only real change here is the variable costs. So we still have profit is equal to total revenue minus total cost, and total revenue is still going to be some unknown price times volume, which in this case is going to be 10,000, the volume of 10,000 visits times P. And then total cost is going to be the direct fixed cost plus the overhead, which is 550, plus $10 per visit in variable cost times 10,000 visits. That's 100,000. So total cost in this case is going to go up to 650,000. So at break even, remember, profit is equal to 0. So that's equal to 0 is equal to total revenue minus total cost. Well, we said total revenue is 10,000. P minus total cost, which we said is going to be 650,000 at 10,000 visits, right? And then we add 650 to both sides. Divide both sides by 10,000, and we get P is equal to 65. Then if we assume, as in the second part of part A, we assume we want to make a profit of 100,000. We still have 10,000 P. All right, we're just going to go back up here and take the cost structure or the profit function and bring it down. The only thing that's changing is our profit target, and it's changing from 0 for break even to this arbitrary 100,000 level. And now we add 650 to both sides, so we get 10,000 P equals 750,000. Divide both sides by 10,000, and you get 75 per visit. Part C says, return to the data given in the problem. Again, repeat part A, but assume that direct fixed costs are $1 million. Okay. So we're not making some really complex changes here. So now we have variable costs. So we're returning, okay, so now we have variable costs back to 5 per visit. Direct fixed costs are $1 million instead of 500,000. Overhead is still 50,000. And number of visits is still going to be 10,000. So profit equals total revenue minus total cost. Total revenue still in this case is going to be some unknown price times 10,000, right? So we'll write that as 10,000 P. Total cost in this case is going to be the sum, the fixed cost, which is the sum of the direct fixed cost plus the overhead. So that's 1,050,000 plus the variable cost, and the variable cost is going to be 5 times 10,000. So we get 5 times 10,000 is 50,000 plus 1,050,000. That's 1,100,000. So total cost in this case is going to be 1,100,000. Total revenue is going to be 10,000. So if we want to set profit equal to 0 and then calculate P, we're going to have total revenue minus total cost. So total revenue 10,000 P minus total cost 1.1 million. So now add 1.1 million to both sides so we can get rid of it. So we get 10,000 P, 10,000 P equals 1.1 million. Divide both sides by 10,000 and we get P is equal to 110. So in order to break even when we raise the fixed cost to $1 million, they're going to have to price at $110 per visit just to break even. Now, if we raise that profit requirement to 100,000, then all we're going to do is change this portion of our equation. So 100,000 equals 10,000 P minus 1.1 million. Add 1.1 million to both sides, we get 10,000 P equals 1.2 million, and then P is equal to 120. For part D, we're going to assume variable cost is $10 per visit, direct fixed cost is $1 million, overhead is 50,000, and number of visits is 10,000. So again, profit function, total revenue minus total cost equals profit. Total revenue is still going to be that P times 10,000 visits, or 10,000 P. Total cost is going to be the total fixed cost, which is the direct fixed cost plus the overhead, or 1050, plus the variable cost. So in this case, it's going to now be 10 times 10,000. So we have 1050 plus 100,000. So total cost of 1,150,000. So combining total cost and total revenue, so we have profit is equal to 0 at the break even. Total revenue is 10,000 P minus total cost, which is 1,150. Add 1,150,000 to both sides, we get 10,000 P equals 1,150,000. Divide both sides by 10,000 and we get 115. And if we decide to set profit equal to 100,000, then we're simply going to take this profit function, the same profit function, set it equal to 100,000 instead of 0, which is the break-even condition for profit. Add 1.15 million to both sides. That gives us 10,000 P equals 1,250. So 10,000 P equals 1.25 million. Divide both sides by 10,000. P equals 125.